Good morning students, myself Dr. Ganesh. I am working as an assistant professor in Department of Statistics, KTHM College, Nasik. In this session, we are going to see the example of one-way ANOVA, which is you already studied one-way ANOVA. So in this example, we are going to check whether there is a significant difference between different treatment means or not. And second part of this session will be Tukeys test. Tukeys test is used for pairwise comparison. If H0 is rejected in one-way ANOVA, then we have to go for pairwise comparison. And for pairwise comparison, the Tukeys test is used. So in this session, we will going to see the Tukeys test, an example of Tukeys test, how to use this Tukeys test. Hello students, in this lecture, we will going to see the example of one-way ANOVA. Look at here. A product development engineer is interested in investigating the tensile strength of a new synthetic fiber that will be used to make cloth for men's shirt. Strength is usually affected by the percentage of cotton used in the material. Now, there are five types of five treatments. We can call this as treatment because this is cotton weight used in percentage to make a men's shirt, cloth for men's shirt. So for each treatment they had taken 5 observations. So N1 is 5, N2 is 5, N3 is 5, N4 and N5, all these values will be 5. Now we have to analyze this data. Means we have to analyze whether the average strength, these are values of strength, whether average strength of each of this treatment is same or not. And we used to solve this example, which is by using one-way ANOVA. To solve this example by using one-way ANOVA, we have to write the hypothesis. You know that the hypothesis in one-way ANOVA is H0. There is no significant difference. There is no significant difference between strength of cotton weight in percentage versus, you know that the H1 in this case is at least 2 strengths of different cotton weights. Different cotton weights differ significantly. Now, if H0 is accepted, this means the strength of all these 5 treatments will be same. And if H1 is accepted, then this means at least 2 treatments strength differ significantly. So to test this hypothesis, first we have to calculate the treatment total and treatment mean. So I am going to calculate treatment total here and treatment mean is here. Treatment total is usually denoted by yi dot and treatment mean is usually denoted by y bar I dot. Treatment total means y1 dot means 7 plus 7 plus 15 plus 11 plus 9. So this value is it will become 49. And mean means y bar 1 dot means 49 divided by 5. Now 49 divided by 5 will be 9.8. So similarly, this y2 dot means addition of these 5 observations, and this will be 77. Its mean 77 divided by 5 will be 15.4. Third one, addition of this 5 observations will be 88. You can do this calculation on calculator, and here this will be 17.6. Y4 dot will be 108, and its mean will be 108 divided by 5 will be 21.6. Y5 dot will be 54, and y bar 5 dot will be 10.8. To find sum of squares, we required y dot dot also. So y dot dot means total of all observations. Total of all these observations or total of this one will be 376. And y bar dot dot means mean of all observations. This means 376 divided by, there are total 25 observations. So 376 divided by 25 will be 15.0. So after calculating treatment means and treatment totals, now we are ready to calculate this sum of squares. So here number of treatments, k means number of treatments. So how many number of treatments are there? Number of treatments, 5 treatments are there. And capital N means total number of observations. Total number of observations are 25. Alright. To find sum of squares. First find out correction factor. How to find correction factor? Correction factor is obtained by y dot dot square divided by capital N. Y dot dot is 376, so 376 square divided by capital N is 25. After doing this calculation using calculator, you will get the value of correction factor as 5655.0. Right? Now, to find SST means total sum of squares. Total sum of squares is obtained by using this formula, summation I running from 1 to k, j running from 1 to ni, yij square minus correction factor. Here yij square means double summation yij square means you have to square and add all these observations. So this means 7 square plus 7 square plus 15 square plus up to 11 square. This double summation will be 6292 minus correction factor. We already obtained this one. This is 5655.04. So this SST will now become, this minus this become 636.96. Alright. Now SS treatment. To find SS treatment, you know the formula for SS treatment is 1 upon k summation I running from 1 to k yi dot square minus correction factor. Here k means number of treatments and number of treatments are 5. So this means 1 upon 5 y1 dot square plus y2 dot square plus up to y5 dot square. This is your y1 dot. This is your y1 dot. This is your y2 dot. This is y3 dot, y4 dot, and this is y5 dot. Similarly, this is y bar 1 dot, y bar 2 dot, y bar 3 dot, y bar 4 dot, and y bar 5 dot. So y1 dot is 49. So y1 dot square means 49 square plus 77 square plus 88 square plus 108 square plus 54 square minus correction factor. Correction factor is 5655.04. So after solving this using calculator, you will get the answer 475. This answer of this one is 475.76. SS treatment is 475.76. You know that SST is equal to SS treatment plus SSE, sum of squares due to error. By using this formula, you can find SSE as SST minus SST, total sum of squares minus sum of squares due to treatment. Now, SST is 636.96 minus SS treatment is 475.76, and after subtracting this value from this one, then you will get the value of SSE as 161. So we obtained SST, total sum of squares, treatment sum of squares, and sum of squares due to error. Now we are in the position to write the ANOVA table. And in ANOVA table, the columns are sum of sources of variation, degrees of freedom, sum of squares, mean sum of squares, and last column is of F ratio. Sources of variation in one way ANOVA are treatment, error, and last one is total. Degrees of freedom for treatment are k minus 1. In this case, k is 5. So 5 minus 1 becomes 4. Here, error degrees of freedom, this is k minus 1. So k minus 1 becomes 4. Error degrees of freedom are n minus k. Capital N is 25. There are 25 observations. And 25 minus 5 becomes 20. And this one is n minus 1. Capital N minus 1 becomes, capital N is 25. So 25 minus 1 becomes 24. Or addition of these two will be 20. Sum of squares due to treatment, we obtained it. It is 475.76. This one is SSE will be 161.2. And this is total sum of squares will be 636.96. To obtain mean sum of squares usually obtained by sum of squares divided by respective degree of freedom. So here MS treatment is obtained by 475.76 divided by 4. This value will become 118.94. MSE means sum of squares due to error is obtained by sum of squares due to error divided by 20. So this will be 161.2 divided by 20. This value becomes 8.06. Now F ratio is obtained by MS treatment divided by MSE. So 118 divided by 0.94 divided by 8.04. 118.94 divided by 8.06. This will become 14.756. 14.756. So after obtaining this F ratio, this is called calculated value of F. This F usually follows F distribution with A minus 1 comma F minus A. That is, this F will follow F distribution with A minus 1 is 4 and N minus K is 20. So this F follows F distribution with 4 comma 20. So table value is obtained from statistical table. Table value is F at 5% level of significance. Table value of 4 comma 20 comma 0.05. This is obtained from statistical table. This value is table value is 2.87. 2.87. Now look at here. Here calculated value is 14.7566 and table value is 2.87. If calculated value is greater than table value, then usually we reject the H naught. In this case, our calculated value F is greater than table value of 4, 20, 0.05 and 5% level of significance. That is 14.7568. This calculated value is greater than table value, which is 2.87. And Hence, in this case, we have to reject the H0. H0 at 5% level of significance. Means, rejecting H0 means we have to accept the H1. And accept the H1 means our conclusion, last conclusion will be at least two strengths of different cotton weights differ significantly. Means their strengths, average strength is not same. Average strength of these 5 different elements is not same. Means there is significant difference between at least 2 treatments. Now, to check the pairwise comparison, for pairwise comparison, we are going to use the Tukeys test. In Tukeys test, we can compare which 2 treatments differ significantly. Means whether there is significant difference between this first and second treatment, first and third. So all these pairs will be going to tested by the Tukeys test. Tukeys test is used for pairwise comparison. In Tukeys test, we test H0 mu I is equal to mu j versus H1 mu I is not equal to mu j for at least one pair I comma j. Means in this Tukeys test, we will going to compare the pairs. So for pairwise comparison, Tukeys test is used. In ANOVA, when H0 is rejected, then we go for pairwise comparison. Here, our H0 in this example, our H0 is rejected. Means we want a pairwise comparison, whether there is significant difference between these treatments or whether there is significant difference between these 2 treatments. So all pairwise comparisons will be done by using this Tukeys test. So Tukeys test use the studentized range statistics. So Tukeys procedure used the studentized range statistics. Which is Q. Q is y bar max minus y bar mean. Now y bar max means the maximum observations from this y bar, and y bar mean means minimum observations from this y bar, and under root of MSC upon. So Tukeys use the studentized range statistics where y bar max is maximum mean from this one and y bar mean is minimum mean from this one. MSC is mean square error is obtained in ANOVA table, which is in this example it is 80.06, and n means number of observations due to each tree. So Tukeys has sent this MSC in this side and y bar max. Now y bar max minus y bar mean becomes Q into under root of MSC upon n. So he defined one statistics which is T alpha. So he defined T alpha as Q alpha P comma F, Q alpha A comma K comma F, not P comma F, is here A comma F. F means error degree of freedom into under root of MSC upon n. So after sending this MSC by this side, then y bar max minus y bar min become Q into under root of MSC upon n. So he defined the statistics like this, where K means number of treatments, and F is error degree of freedom. In last example, our error degree of freedom is 20. Here This Q alpha P comma F, Q alpha P K comma F is obtained from table of studentized range statistics. Table of studentized range statistics. So there is one table called studentized range statistics. Alpha is level of significance, K is number of treatments, and F is error degree of freedom. So for different values of alpha, K and F, the table is given, and this is obtained from the table of studentized range statistics, which is statistical. Conclusion. Tukey's procedure, Tukey's test declares two treatment means are significantly different. Two treatment means are significantly different if absolute difference between their treatment means, absolute difference between their sample means, exceeds L. If absolute difference between their sample means exceeds the alpha, then we can say that their corresponding treatment means are significantly different, otherwise not. Means, what do you mean by absolute difference? Absolute difference means, suppose you can take y bar 1 dot mod of y bar 1 dot minus y bar 2 dot, means mod of 9.8 minus 15.8. If this value exceeds the alpha, then we can say that this mean of these two treatments, first and second treatment, differs significantly, otherwise their means are same. To use Tukey's test in this example, Tukey's test of the last example, you know that in last example H0 is rejected, means at least two treatment means differ significantly. So to check which treatment means differ significantly for pairwise comparison, we are going to use Tukey's test. In Tukey's test, you know that H0 is, we had seen this one, H0 is mu I is not mu I equal to mu j, versus H1 is mu I is not equal to mu j for at least one pair. I comma j. Here, this means we are going to check whether mu1 equal to mu2, mu1 equal to mu3, mu1 equal to mu4, mu1 equal to mu5. Similarly, mu2 equal to mu3 or not. So all these pairwise comparisons we are going to done by using this statistics. The statistics used by Tukey, which is T alpha is equal to Q alpha A comma F into under root of MSC from N. Here we are going to use alpha as 5%, so T 0.05 will become Q 0.05, comma here K is number of treatments are 5. F is error degree of freedom. Here error degree of freedom, you know, ANOVA is 1, and under root of MSC is 8.06 divided by N, means number of observations due to each treatment, and here number of observations due to each treatments are 5. So Q alpha K comma F is obtained from table. So by using table of studentized range statistics, this is obtained from table. So after putting this value, you will get T 0.05 will be this value Q 0.05 5, 20 is obtained from studentized range statistics table, and this value will become 4.24. So 4.24 into this root of 8.06 divided by 5. So after solving this using calculator, you will get the value of t.05 as 5.383. So this is your TF. Now we are going to find the absolute difference between each pair of treatment means, and if that absolute difference exceeds this 5.3 alpha means 5.3832, then we can say that corresponding pair of means are significantly different, otherwise it is not. So thus any pair of treatment averages that differ in absolute value by this 5.3832, then we can say that the corresponding treatment means differs. Here we are going to find the absolute difference between each pair of treatment means. So start from first versus second. So 1 versus 2. So 1 versus 2 is y bar 1 dot minus y bar 2 dot. Y bar 1 dot is 9.8. So absolute difference between 9.8 and this 15.8. So absolute means mod means if the value becomes negative, then convert this into positive value. So mod value is always positive. So 9.8 minus 15.4, this will become minus 5.6. But because of this mod, it will become 5.6. Right? And here 5.6 is better than this 5.832. Yes, we can say that the mean of these two treatments differ significantly. This means actually u1 is not equal to u2. So I am going to give star here. Whenever the absolute difference exceeds this t alpha, I will going to denote this by star. Take first versus third, y bar 1 dot minus y bar 3 dot. So y bar 1 dot is 9.8 minus 17.6. So this absolute difference will become 7.8. 7.8 also better than this 5.3832. So I will going to give star here. The star value indicates the corresponding treatment means differ significantly. Right? Now take y bar 1 dot 1 versus 4, y bar 4 dot 9.8 minus 21.6. This absolute difference will become 11.8. So 11.8 is also greater than this 5.382. Now take 1 versus 5. This absolute difference becomes 9.8 minus 10.8. This will become 1. Now 1 is less than actually this 5.332. So no need to do star here. This means actually this treatment means of this first and fifth one will be set. This mu1 equal to mu5. Now 1 versus each of these is over. Now start from y bar 2 dot minus y bar 3 dot. Y bar 2 dot is 15.4 minus 17.6. So this will become 2.2. So 2.2 is also less than this one. If their corresponding means are not significant. Y bar 2 dot 2 versus 4. So this will become 15.44 minus 21.6. This absolute difference 6.3 is better than this t alpha. So I had to get here star. 2 versus 5, y bar 2 dot minus y bar 5 dot. So this will become 15.4 minus 10.8, and this value will be 4.6. This value is 4.6. Now 4.6 is less than this 5.3832. Now 2 versus all these is over. Now start from 3. So y bar 3 dot minus y bar 4 dot. This absolute difference is 17.6 minus 21.6. So this absolute difference will become 4. So 4 is also less than this 5.3832. Now 3 versus 5. Y bar 3 dot minus y bar 5 dot. This will be 17.6 minus 8.8. This absolute difference will be 6.8. Now 6.8 is also greater than this 5.3832. So I have written here star. Now 3 versus all this is over. Now take 4 versus 5. Last pair, which is 4 versus 5, and this will be 21.6 minus 8.8. This absolute difference will be 8.8. Here also I have written star because this 10.8 is greater than T alpha 5.383. So this means the start value indicates, we can write the conclusion of all this in one statement, which is the start value. The start value indicates, start values indicates the corresponding treatment means. Corresponding treatment means prefer. So in Tukeys test, we can check all pair of means by using one size, which is T alpha. So meaning of this one means mu1 is not equal to mu1 is not equal to mu2, mu1 is not equal to mu3. Here there is a star means mu1 is not equal to mu4. Here there is no star means mu1 is equal to mu5. So these two treatment averages are same. This means mu2 is equal to mu3. This means mu2 is not equal to mu4. This means mu2 is equal to mu5. This means mu3 is equal to mu4. Here this means mu3 is not equal to mu5. This means mu4 is not equal to mu5. So all these conclusions I have written in one line. This the start value indicates, wherever there is a star, this indicates the corresponding treatment means equal significant. In next lecture, we are going to see the different tests for pairwise comparison. So tests for pairwise comparison. There are another tests for pairwise comparison, just like your Tukeys test. Fisher's LSD test. Fisher's least significant difference test. There is another test which is called Neyman-Cayeux test. Neyman-Cayeux test. Also, there is another test which is called Duncan's multiple range test. Duncan's multiple range test. So these tests are used just like your Tukeys test for pairwise comparison. In this all this test, we will going to test H naught, which is mu I is equal to mu j versus it is not equal to mu j. Mu I is not equal to mu j. So to check this one, these three tests are used just like your Tukeys test. In next lecture, we are going to see these three tests.